first and foremost, this segment is a segment that connects the point, or the midpoint, sorry. A segment that connects the midpoint of two sides of the triangle. Okay, so a segment that connects the midpoint of two sides of the triangle. So we just did midpoints by just measuring and taking half of that length to find the middle. So let's make sure we remember how to do it with our compass. Do we remember how to do it with our compass? Maybe, hopefully, potentially. All right, so if you've got your compass, so let's find the midpoint of the left side here. So you're going to put pointy part. Now be careful, because the ones I gave you are really pointy. Pointy part on one end point. And then you're going to stretch the pencil so that it goes beyond where you think the middle of the line segment would be. And then swing an arc that goes through the top and the bottom. So you're going to get something that kind of looks like this. I can't do it because mine is not. Yeah, I would go more, because you want to be able to intersect. So I would go a little bit more in the interior too. And then preserving that same length, do the same thing from the other end point. And swing it. And you should hopefully get your two arcs to intersect. If they don't, then go back and extend the other one far enough so that they do intersect. So you need them to intersect on both the left and the right side. And then once you have that, use your ruler as a straight edge. Line up both points of intersections of your arc. And then just put a marking where your midpoint is. All right, so to show that that's a midpoint, I'm going to turn that into a dot. Turn your midpoint into an actual dot so it looks like a point. And then let's put single tick marks above and below. So that shows us that we have the two congruent segments, right? That's how we know we have something as a midpoint. Okay, now can you do the same thing to this right side? Go ahead and do it. So find the midpoint using your compass. Swing your arcs. I'm cheating, I'm just going to eyeball it. You're running off the paper, maybe make your distance between pencil tip and pointy part of your compass a little bit shorter. And then once you have those two midpoints, connect just those two. Let's see how good of a job you did.
Is it in straight line?
Yeah, you make a straight line connecting those two midpoints. All right, so there we have a mid-segment. So now what I want you to do, I would suggest probably using centimeters. Can you measure the length of this bottom side? Be as exact as you can. How many centimeters is it? 10.5-ish. 10.5 to 8. It's a pretty big difference. Where are we going? 8, 7, 6? Which one is it? 6? All right, we'll go 6. Why not? All right, so let's label this 10.6 centimeters. Now can you measure that the mid-segment length? What is it?
I think it's 5 centimeters.
5. If you did it exactly right, it should be 5.3 centimeters. Or hopefully you're somewhere close to that. So what do we notice about the relationship between my mid-segment and the third side that I didn't find a midpoint on?
It's half.
It's half the length. And that will work every single time. So this mid-segment right here should be half the length of that right there. This mid-segment should be, thank you, half the length of that one right there. And that should work every time. What else do we notice? What do you think is the relationship between this line and this line? Parallel. What do parallel lines get us? They get us congruent angles, right? In this case, we were getting corresponding angles congruent. Corresponding angles congruent too. And if you wanted me to prove it to you, I could get the protractor out and we can measure them. You just want to trust me that that's the case? We're going to trust the process. Okay, so we have our mid-segment that we just constructed. Let me just quickly get this on here for the video. So we found the midpoint, connect it. We said this was 10.6 centimeters, and this was half. So I did not do a very good job estimating that. And we know that it's parallel, so I get congruent corresponding angles. Alrighty. Okay, so the mid-segment theorem tells us the following, that the mid-segment of a triangle, so the mid-segment theorem says the mid-segment of a triangle is parallel to the third side and is half as long as that side. Okay, so the mid-segment of a triangle is parallel. Why do I care about that? Well, that gets me my congruent angles. It's parallel to the third side and is half as long as that side. Okay, so let's go through some easy ones first. Very good. Is X on a mid-segment or on a third side? Mid-segment, right? So since it's a mid-segment, that means it's half of the third side. So X is equal to half the third side, which is 18. I'm just writing this out for now. So X would be equal to 9. Right? Which if we use common sense, it kind of looks like it's half, right? So just don't ever make them equal. Students will do that. We're like, oh, X is 18. Well, does it look like it's 18? No, it doesn't. It definitely looks smaller, right? That's not as long as that. So then think in your head, well, if it's smaller, what could it be? Oh, it looks like it could be half. Sure. Okay, so X is equal to 9. So for B, X is still at my mid-segment, but now instead of just X, I have a 5X is equal to half my third side, which in this case is 70. Half of 70 is 35, is equal to 5X. Dividing by 5 tells me X is equal to 7. Questions so far? Nothing too complicated? Okay. So now let's move on to the back. So now we're going to try to make the algebra a little bit more challenging. So here we have same diagram. We've got different situations happening. So here we have AB is 3x plus 8. Is that AB the mid-segment or the third side? Mid-segment. So I'm going to put a little mid here just for my own note. GJ, is that the mid-segment or the third side? That's the third side. So I'm going to put a little third there. So we know that, so I'm going to put a little star here just for reference. We know that my mid-segment is equal to half, I purposely didn't spell segment out, the third side. So let's set up our equation. So my mid-segment is 3x plus 8 equals 1/2 times my third side, which is 2x plus 24. Why is my right side nice? Well, everything over here is even, so it's going to be easy to take half of 2x and half of 24, right? When would it not be so nice? When they're odd, and then you're going to take half of odd numbers and get fractions. What's one way I could get rid of this fraction instead of distributing it? Couldn't I multiply by the reciprocal? Yeah, and then do that. But let's distribute it here because we can. So half of 2x gets me 1x. Half of 24 gets us 12 is equal to 3x plus 8. Subtracting x from both sides gets us 2x plus 8 equals 12. Subtracting 8 from both sides gets us 2x is equal to 4. Dividing by 2 gets us x is equal to 2. Not done. What's the length of AB? Plugging that in. So AB is equal to 3 times 2 plus 8. So 6 plus 8 is 14. Okay, we see how that works? We'll be okay. I know you're hungry, Marlene. All right, got that? All right, let's jump to B. So GH. GH is my third side. BC is the mid-segment that's parallel. So remember, it's mid-segment. So my mid-segment, 4z minus 3 is equal to half of 7z minus 1. Here it's not quite as nice to take half of 7 and 1 because they're odd. So let's multiply by 2, which is going to cancel that out. But then when you multiply by 2 over here, you have to make sure you double everything. Don't just double the 4z. Make sure you double the negative 3 also. So that turns into 8z minus 6 is equal to 7z minus 1. Subtracting z's gets us z minus 6 is equal to negative 1. Adding 6 gets us z is equal to 5. We're finding GH. So GH is equal to 7 times 5, which is 35 minus 1, which is 34. So GH is equal to 34. Okay? Questions with that? Good? All right. Next one. We got a diagram here. Can we find all of these lengths? So what are we given? We're given that U to V is 80. So if U to V is 80, what would be HE? 40. It's going to be half of that, 80. Good. What is, okay, so what else were we given? We're given TV is 100. So what would be ED? 50. Good. What else are we given? We're given HD is 80. So let's write that in. What is T to U? Yeah, if HD is 80, then T to U is 160, doubling that 80. What's T to E? 80, because it would be half of the 160. Good. So we got our 80, which would make this be 60, which makes this 80, which makes that 80. VD and DU would be 40. HV and TH would be 50. Okay. All right, let's just intro coordinate proof. We won't do the physical last one with the proof. We won't have time for that, but I think we can get through at least the first example. So a coordinate proof is this. And if you just want to write the first sentence, just write the first sentence. It's a proof. So a proof that involves placing geometric figures in a coordinate plane. I would just write that. Don't write anything else. Okay. So in theory, when you use these variables to represent your vertices of whatever the shape is that you're putting in the coordinate plane, it should work for any type of geometric figure. Okay. So we got to smartly place a figure. So we're going to place a rectangle into a coordinate plane and give coordinates to them. And then we'll get to the proofing part next class. So first smart choice is always put things in quadrant 1, because everything's positive in quadrant 1. And always use the origin. Why is the origin nice? Because it's all zeros, right? And zeros are nice numbers to work with. So let's make a quick quadrant 1. Oops, let me move this up. Quadrant 1 as such. All right, can we put a rectangle there so that the lower left corner is at the origin? Sure. All right, so let's make a rectangle. Here's my rectangle. I did it in red. So now let's label our vertices. This vertice is at 0, 0. This vertice to the right here, is going to be some number, which we don't quite know what it is. So we're going to use a variable. What variable would you like to use? X. Good choice, because we're on the x-axis. So x comma 0. What about this one over here? Top left. 0 comma y would work. Which would then make our final vertex what ordered pair? X comma y. Good. Okay, so we placed a figure in a coordinate plane. We made vertices with variables. If I would have made this A, and if I would have made this B, then that would just be AB, right? So it doesn't necessarily need to be XY every time. XY is nice because we have an X and a Y axis, so it's easier to understand. All right, can we do the same thing for a scalene triangle? What will that look like? So let's make our first quadrant. Scalene triangle, what I know about that? No sides congruent. Does it mean that all the angles have to be acute, all the angles have to be right, or right obtuse? No. Why would it be smart to make a right scalene? Because I just need to make a diagonal line straight across, right? So let's do that. So kind of make something that looks like this. So here I have 0, 0. Here we have 0, y. And here we have x, 0. If this would have said isosceles, then what would need to be true about this variable? They would have to be the same, to be the same length. So if this is x units, then this has to be x units. Does everybody see that? Okay. All right, we'll stop there. Let me give you the homework. Let me see if there's anything that I need to take off from the